Welcome everyone to EROSS DR online summer seminars. Thank you very much for being here. We are in the week right before ER. So next week, please tune in to the International Conference on Conceptual Modeling. I'm Giancarlo Guizzardi, and I've been organizing this together with Enrico Franconi, Claudenir Morais, and Tiago Sales. Tiago is not here today because he just became a father a few hours ago. So I would like to dedicate EROSS today to Davi, his son. So Davi, welcome to this crazy and wonderful world. Our guest today requires no presentation in general in computer science, but especially not in this community. We have here today the founder of the International Conference on Conceptual Modeling, the person who brought all this whole community together, and the inventor of the entity relationship model, Professor Peter Chen. The entity relationship model, of course, all of you know that it's a widely used de facto standard for conceptual modeling, data modeling, also in industry. His original paper presenting the ER model is one of the most frequently cited papers and one of the most influential papers in computer science. As I said, he created the International Conference on Conceptual Modeling 4 decades ago. So the first edition was organized in 1979 when he was still at UCLA. Over the years, Professor Chen has been affiliated to many institutions, including Harvard, where he did his PhD, MIT, UCLA, Carnegie Mellon, and the Louisiana State University, in which he was a professor for many, many years. He has received a number of honors, including the IEEE Harry Good Award, the ACM AAAI Alan Newell Award, the Dama International Achievement Award, the Stevens Software Method Innovation Award, as well as fellowships at IEEE, AAAS, and ACM. Also, he's an ER fellow, and but also to recognize his pioneer leadership role. Elsevier created in 2008 the Peter Chen Award, which was established to honor excellent researchers, educators for their outstanding contributions to the field of conceptual modeling. And we had many Peter Chen Award winners in this series of EROSS talks. So, so today, in a sense, we go to where it all began. So I couldn't be happier than to welcome here today Professor Peter Chen. Peter Chen, welcome to EROSS. Thank you very much for being here.
Thank you, Giancarlo. It's my honor and a pleasure to be here. I probably get a little bit cold, so a little bit the voice is a little hoarse. But anyway, I will speak slowly so that you can. So the talk today is talking about from ancient natural languages to future conceptual modeling. It's basically, I will tell some interesting story in the talk about why people like me get into this particular field. This is the outline of my talk. I will start with the historical background because many of you probably are much younger than me, and so you're probably very familiar with the last 10 or 20 years, but before that, probably you only read from the book or some papers. So I'd like to spend some time to talk about some historical background. So starting some basic ER concept diagrams and talking about how the ERM was developed, and and there's also in the early days, in the 1980s, 90s, in the turn of the century, the conceptual model situation. And then what triggered this conceptual model movement? The next topic I'd like to address is on the modeling principle. We've been talking about modeling, conceptual modeling. We talking about theoretical foundation. But one of the important things is to look at what are the fundamental principles, okay? And interestingly enough, it turned out quite similar to several natural languages, particularly Asian languages. So I attended some of the talk in this ERO online summer series. So there are quite a few papers talking about different languages and also the languages and conceptual modeling. So I think there's an important thing we can look into that. Why are we interested in this kind of natural languages? I think one of the important things is because conceptual modeling, or whether it's the ER model or some other models, basically try to use some kind of notation to convey our mental model of the world. So we want to communicate that to other people. So that's a communication mechanism. Similarly, the natural language is the same. It's trying as a way to communicate your idea, your mental picture, your idea to somebody else. Or you can write it down and passing it out. Now, so we look at several languages. Look at the English, Chinese, Asian, Egyptian hieroglyphs. Okay. Then we talk about, okay, so if we develop this kind of principles, can these principles be applied to other problems? Now, the last things I will talk about is talking about the future conceptual modeling. In the last 2 months, there have been several talks talking about this subject, particularly the last one, Professor Berheim is talking about the theoretical foundation of that. So some of the issues he mentioned, and I like to re-emphasize here, I think they are important. And I also will talk about some success factor, how to make the research be successful. Now, so let's start with the ER model. So basically, it's a view of the world consists of entities and relationships. Now, in some way, some of you probably are religious, okay? And I think in the Oriental philosophy, they also have different kind of religion and different kind of philosophy. So one of the famous philosopher in China is he proposed something called Taoism. Okay, means he tries to say the whole world consists of one unique concept, and from that concept split into two. One is yin, the other is yang. Okay, or negative, positive, whatever. So, in the ER model, in some way, is similar to that. So have something called entities and a relationship. So those the fundamental concept of that. And later on, and I think both in my talk and also in many papers of a lot of people publish and talks, concentrate on both the fundamental concept of that as well as application of this crucial concept. So it is a very widely used, and then later we talk about why it's popular. And I will keep on emphasizing the important thing is it's natural to human thinking. Okay? So why it is popular is because it's natural. So people easy to understand, easy to adopt, easy to use. So we look at two individuals. You can see there are two persons, entities, and then they have to play different roles. Your husband, wife, or right now could be both husband, both wife, whatever. And I think I'm partial Catholic. What I mean partial means I used to go to church very often, but not as often as before. Now, I think many of you probably heard about the Pope recently also support civil reunion. So the role could be changing, not the very fixed type of roles. Okay? A person married to another person. So later on, noun similar to entity and verb similar to relationship. So this is some kind of ER model, entity and relationship with attributes and attribute types, value types. So basically, some mathematical foundation, set theory, modern algebra, logic, and letter theory. And so you can see we can define entity set, value set, relationship set. Now this kind of thing being extended to more complicated form. One thing we look at here is the relationship is defined as a mathematical relation on entity sets. So basically, it's a collection of individual relationships, but each one is an order tuple, means the order is important. Okay? So the next thing we want to do is to look at how the ER model was developed. Okay? So there are a lot of questions. How come nobody or very few people proposed it before? Now, this question should be rephrased a little bit, restricted a little bit, because the concept of entity relationship being discussed around for many, many years, maybe thousands of years. So nothing completely new. Okay? What's new here, what has been new so far in the last 40 years or so, is because it has some formal mathematical type of definition, as well as some diagrammatic technique to capture that in a diagrammatic form. Now, you may think about why. Okay, I will give you one answer and then give you another answer. One answer is right place, right idea, at right time. It doesn't mean myself. If anybody, if you have a good idea, if you don't present it in the right place or the right time, sometimes doesn't work. Let's look at the situation in the database community. Is for the software hardware vendors, they want to integrate different format, different things, put more data semantics. And then for the user organization, they want to have a unified methodology and for different file database format and incorporate more business rules. Now, 1973, I graduated from Harvard. That time I was working on mathematical optimization, optimal file allocation. But then, after that, I joined Honeywell. That time was a computer company. There are two branches. One is computer, the other control. Later, they sold the computer division to somebody else. So I'm working with 10 people, architecture team, to work on something called next generation distributed system. We're together with quite a few database experts, like Mr. Bachman, the Turing Award winner, and Lefkowitz and John Lyon, both have written data dictionary pair books and database books. Then I joined MIT Sloan School of Management, 74, interact with user organization. For the user, they want something else. They want something, a modeling methodology, design methodology, they can apply to any kind of systems. Okay, not just one type of system, but many kind of system. So that time I finished the ERM paper, and but most other faculty researchers around the world were busy implementing different kind of DBMS, either relational or causal type of networks. So I wrote the first paper. That was actually the first paper on the volume 1, number 1 of the HCM transaction on database system. Now, the initial reaction for my first paper was saying, oh, most people were fighting between relational and the network model. Then I was the new kid on the block, so proposed something new. So get a lot of criticism. So the advice I got is basically, some people say, drop the model, you join one of the religious camp. Okay? So because that time I was just assistant professor, and so it's very crucial to, some people say, if you keep on doing this, you may not work for your academic career. But I believe myself, so I persist with that and wrote a paper, and then organized the first year conference at UCLA, the second 2 years later, the third one another 2 years, then later on every year. Now, we talking about the early days. As you can see, here, I was in the management school of MIT. At the same time, there's another assistant professor, Professor Mike Hammer, at the ECS. He's also developed a model, and that's called semantic data model with his student. And then later on, he left MIT and wrote a book on reverse engineering and doing consulting on that subject. Basically applying what we learned in the computer field and to the management field. Unfortunately, he passed away a while ago. Now, the next one is the US Air Force have integrated computer-aided manufacturing called IDEF project. So I served as a consultant there, and the ERM became the basic of IDEF. It's a modeling diagrammatic technique used widely in the Air Force, United States. So many companies started to do that. Then also caught and find out, oh, there are growing interest in this ER concept. So he developed something called RMT model. And Bachman did the same, called partnership model. Okay. Interestingly enough, Dr. Cart and Mr. Date, they not only wrote a book together, but also developed something, a conference together, and invited me to join him as keynote speaker in Europe, in England and Europe. And so that was an interesting type of association with him. Then the IRDS, this is basically the data dictionary. I think in Professor Berhan's talk last week, he mentioned about the multi-level modeling, recursive model. So actually, the IRDS have that, like 3 or 4 levels of meta models. Now, the computer-aided manufacturing, so that's another area being used widely. So then you can see the different kind of tools, even today, still have that, okay, and people widely use that. And UML, most of us knows about that. Also have some component on the conceptual data models. So the OO data mining, okay, and that's the turn of the century. So now let's talk about something called the what triggered conceptual model movement. I think the important thing is a group of people, very talented researcher practitioners, work together and maybe individually, to push this So anything, one important lesson is if just one person is not be able to move the mountain. So we have to have a group of people together. So then, for me, there's a special situation, a right combination at the right time. What is it? So the situation is this way. I give a talk, particularly in the first 20 years, to around the world. So initially people say, good, 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 good. Then at the second 10 years, they say, gee, how come this idea pop up? Okay, how come you are one of the several few people who push this? Why? Why it's you? Why not me? Okay, so they put it question very straight, and I run into that kind of question many times. So it turned out to be, if I think deeply, it's a mixture of culture, Oriental culture, with the Western culture. The Chinese character kanji basically use the modeling principles. So we're going to see later. They are related. Now, why do I keep saying that? Because when I was a student, PhD student at Harvard, a famous architect, I.M. Pei, he also designed quite a few famous buildings, including the Louvre Pyramid. So he is a graduate of Harvard Architecture School. So he went back to the Chinese American Association at Harvard and give a talk. Okay. Suddenly we all say, great, see this famous guy. And but the important lesson I still remember today is to say he keep on telling us the reason he can make a unique design of different building is because his Chinese background and his American training and background. So he said, because this combination will make him unique compared with other people. So he also don't be decided by yourself. Tell you, he said, you come from Asia. You may not speak very well English. You may not know the culture or custom in the Western world. But however, you will know that actually is not your disadvantage. It could be your advantage. Okay? So that's the reason I want to share with you, not only share with you about the modeling principle, but I also want to convey to you the lesson I learned from Mr. I.M. Pei. Everything you think you may be not good as other people, actually you can turn that become your advantage. And also the important thing is the intersection of different culture, different discipline, and different things. So we will continue to stress that later on. So let's start with the English. Okay. So we will look at the English, Chinese, and Egyptian. So I started to talk about the second year conference later on. So they're actually a large consulting company. They call me up, want to give the paper to a lot of system analysts so that they can convert from the English requirement statement documentation to the ER diagram. So basically, you can see, noun equal entity, and whether it's common noun or proper noun, whether it's a transitive verb or intransitive verb. So you look at that, you can decide. Okay, so John Kennedy is a proper noun. It's actually it's a name of the entity. Okay, if you want to be very precise. The other concept is to say, if you have product shipped to customer, then the whole thing can be performed by clerk. So what you have here is manager decide which machine assigned to which employee. So you can see here, same thing. This is also, the whole thing is decided by this. Okay? So this is the translation rules from one to the other. So you have entity, property, transitive verb, adjective verb, there. Okay? So many of you are familiar with the unit structure. So we look at the Chinese letter. The history of Chinese written language. Okay, it's a Chinese written language is one of the earliest written languages. Some people say it started many years ago, 4000 BC or whatever, but it's only some of the symbols. Okay, there's not too much symbols, so couldn't convey too much meaning. But later on, I think in about 2000 to 1300 BC, there's more symbol carved into bronze instruments. Then they use the oracle bones to carve the characters. So in 1300 BC is about 1000 characters, and later on, not too many years later, and accumulate about 4,500 characters. That should be enough to convey the old style type of society. Okay. Now, so we look at several principles. One is called principle of physical resemblance. The other is the principle of subset, principle of grouping, principle of composition, aggregation, principle of commonality, principle of instance of a type. So if you look here, this is the original form of the Chinese characters. So this is, we look at the sun. So eventually the book becomes that. Why it becomes this kind of form? Because when you use the knife to carve on oracle bones, it's very difficult to make a circle. Okay, you go this way, you may not come back to the original point. So it's easier to make a straight strike. Okay, so that's the, and this is the meaning of the sun. So this is the moon, and that's the moon. Okay, and so that's the pip. Okay, the sun always has a dot there because of the sun, and then the moon also has some dot there. But I think in some Oriental culture, they think that's a beautiful woman there. Okay, beautiful woman there. Now, the other thing we look at is subset. What is subset? So this is a person. So a person is confined to some room or some building, cannot get out, and don't allow to get out. So what kind of person is that? So that's the prisoner. So the prisoner is a subset of a person. There are different kind of person. You may be a free person, you're not free. Okay, so that's prisoner. Principle of grouping. So you have a tree. So when you have 3 trees together, what is that? You have 3 means many, implies many. So you have many trees. That's a forest. So next we look at the principle of commonality. So this is the sun and moon. You can learn that. Sun and moon together is some special meaning. So the thing we want to ask is, what do they have in common? The sun and moon, what do they have in common? They have the light, they have the brightness. Okay? So it's basically, generate an idea called brightness by night. Now let's look at the principle of composition. It's the mouth and the bird together. So we compound them. What does that mean? Okay, it generates a different meaning. Okay, it's basically the bird singing. The bird is singing, or the noises made by bird. So that's the composition principle. Then there's also a concept of instance of a type. So I have a type versus instance. So let's look here. Those are the three Chinese characters. Now the one I show you is basically right now in the Chinese cultural societies. You have the China, mainland China, PRC, you have Taiwan, Hong Kong, Singapore. Taiwan and Hong Kong are basically using something called traditional Chinese. That's here. That's the one you see here. It's more complicated, more comprehensive type of thing. It's being used for the last 2,000 years. Then I think in mainland China, the PRC, People's Republic of China, they try to move up everybody to be literate. So they simplify quite a few characters. So for example, this word still will be the same meaning, but at the right-hand side will be simpler. Now, as you can see, I want to point out to you, is the left-hand side is the same. So this is iron, this is copper, this is silver. So they all are metals. So on the left part component, the component left part is the metal. Okay, is the metal. So that's the principle. So now we want to ask, can this principle be applied to another problem? Okay. Another problem. Okay? Now, before that, let me say something about Egyptian hieroglyph. Egyptian hieroglyph is also one of the earliest written languages of humankind. So basically started with the early Bronze Age, about 3200 BC. Then going through quite a few dynasty of the Egyptian. So you can see from 32,000 BC all the way to the Coptic period. Now, basically, it's being used less until the middle of here. The middle here is to about 4000 AD. Okay. Then the whole thing get lost. Get lost for about 1400 years. Nobody knows how to read, write, or understand the whole thing. And many scholars spend the time trying to figure that out. Okay. I also went to Egypt, went to see the pyramid, and almost get trapped inside the pyramid. Okay, so it's quite dangerous. Okay, so I probably won't do it again. Now, the other thing is this is a Rosetta Stone, and I think in the British Museum has the original stone, and I think in the Egyptian Museum, National Museum there in Cairo, I went to see there. They have the copy of the stone. Now, the Napoleon army discovered that the reason they can figure out, the hieroglyph is because they have two other languages available: the Greek and the Demotic scripts. So people can understand the other two, and even the stone a little bit damaged, they can just put together and figure out how to read them. So let's look at, we already mentioned about several principles of the Chinese character composition. So the question is, whether we can apply here in the Egyptian construction principles. The answer is yes, we can do the same thing. Okay, so let's look here. Let's look at this side. This is the left arm, or left arm. Then you have the mouth. And then we have the viper. Then we have arm. Then we have the sieve. Okay. Then we have, this is the man, that's the woman. It's interesting, I mean, I'm not the expert of this hieroglyph, even though I purchased 20 books on that. And but you can see, excuse me, I detect for women, they have long hair. So maybe at that time, Asian time, the women also used to have long hair. They have sun, they have house. House, you basically have something to support the roof. Then you have water. One thing I find curious is because there are several characters here, the hieroglyph, very similar to the Chinese characters. For example, the mouth. The mouth, the original Chinese characters were the same. Okay, right now a little bit different because they make it the squares. Okay, a rectangle. So another word is character very similar is the sun. As I mentioned earlier, there's a dot there. Then the water is also very similar. Okay? The Chinese character of water originally that form, but it turned to a vertical and make it three waves. Okay? So that's the water. So what does that mean? It means even people, Egyptian and the Chinese or Japanese, thousands of miles away, they can come up with very similar type of picture of the world, very similar type of symbol to describe the picture of the object. Okay? So some of you probably want to do some research. You can look at that to see your human cognitive way, whether it's always thinking in the same direction, no matter you are coming from Africa, from Australia, or whatever, Asia or Europe. Because now, principle of composition. So you have a house here, then you have something called wood. So then you combine these two together, that becomes a wooden house. The other thing is called principle of grouping. You can see here, this is, we already learned, this is a man. Okay? Now, when they have three bars here, 3 bars means you're tripling. You triple, there are 3 men here. Instead of drawing the diagram, 3 of the men, you make that. So 3 of them means more than a lot of brothers. So here, this is a woman. Okay, woman. Woman, you have 3 women, so that's sisters. Then you have a man, a woman, and the 3 of them, your brothers and sisters. So that's the principle of grouping. 3 means 3 or more or many. Excuse me. Now, the question is, people may raise, can this principle be applied to another problem? Okay, you say, okay, this is, you can apply to data modeling, conceptual modeling, can be applied to Chinese character, English, grammar, and Egyptian. Can that be applied to different problems? Yes. Okay. So the answer is yes. We're going to show you that. And also, the modeling principle are comparable, just not only 3, could be more. Okay. Now, so I wrote a paper on how to use this kind of concept, combination of EIM, English sentence structure, Chinese character, Egyptian hieroglyphs, apply that to the structure icon design. So design, graphic design. Now, we also, I think computer software, there are a lot of icons. Okay. Now, even on daily life, okay, I think in the United States, they have a driver license test. You'll have different kind of highway symbols. So you have to recognize that. Okay. And it turned out to be those highway traffic signs, not only are very difficult to remember. So it's it's easy to make errors. Now, so if we look at the design of the icon, so some of the principles can be used. Some of them we can have a new type of principles, but also from conceptual modeling. So we have the resemblance, composition, but we also have a generalization, specialization, and aggregation. Then we have a models, patterns of models. Pattern, and also the principle of interpretation. So I will talk about that in a few minutes. So there are other things I want to stress. Is we need some principle of naturalness, okay, and the principle of differentiation. Now, what does that mean? Because many icon design probably sometimes we don't use to detect that. We just take whatever give to us. Okay, all the big vendors, be it all the Microsoft, Oracle, and Facebook, whatever, they give you the icon, you just take it. So you don't think deeply. Okay? And if you think deeply, they have to be not only resemble to the natural physical object, but also should be natural to your thinking. It's very important because I remember the change of name. I think one of the largest oil company called Exxon, EXXON. Okay, why did they choose this name? They used to call Esso, ESSO, but later on they changed the name. A while ago they changed the name. Then they looked at different combination of the English spelling and tested around the world. And everywhere, the word may be good in one country, maybe not good in another country. Okay, so finally they find out this particular word with X on two X's. Doesn't offend anybody. Okay, that's the offending type of consideration. You don't want something to be offending somebody. But on the other hand, you want to be natural to that particular culture, particular country. So now, because some people even I think give some example. I give this kind of entity ownership talk in many places. In one particular company, I ran into trouble. When I talk about entity, they say, what is entity? They think about entity as a building, okay? Because they use the word entity as building. Building is entity. Everything else is not entity. So you have to be accustomed to the local culture, local thinking, either a company or a society or a country, whatever. Now, the other thing is called you have to be differentiable with other icon. Differentiable. The principle of composition. So there are other type of thing we haven't talked about. Generalization, specialization. That's many of us probably very familiar with that. Aggregation component. Okay. So the thing is that you can also compose two icons together. Now, the icon methodology should be natural resemblance, differentiation principles, and user-oriented and composition, multi-levels of icon composition. Okay, so this is just rephrasing earlier about multi-levels of modeling. So there are also the pattern of models and the principle of interpretation. Now, what does that mean? Principle of interpretations. Principle of interpretation means, given an icon, how do you interpret its meaning? Okay, you recognize subparts, sub-icon, and find out the relationship among the sub-icons. So, for example, the type and instance, generalization, specialization, aggregation component. Okay? Now, in English or in Latin, or in other phonetic languages, you can see there are some roots of the word or a series of words. Okay? So very similar in the Chinese characters, you also can look at some component. Even you don't know the whole thing means, you recognize part of it. Then you make a guess. Even left part, upper part, right part, lower part, you make a guess. That's one way to guess the meaning. The other thing is, for people trying to learn about Chinese or kanji type of thing, you may not be able to pronounce it because there's no association with pronunciation. However, if you know a component, how to pronounce that, so you can try that pronunciation, sometimes works. So that's the type of thing. You find out the relationship between different sub-icons and make a guess of the meaning, make a guess of the sound, make a guess of what. So then the other thing is interesting, called reading interpretation directions. Not too many people pay attention to this. But let me explain to you, the sequence is important. I think we're all familiar with English left to right and right to and for Arabs and for some of the Indian language, it's from right to the left, and from top to down. I don't see anything from down to up, okay? Yet, maybe somebody find out that and show it to me. Now, I have some personal experience on that, on the left to right, right to left. There's another interesting story, personal story. As you probably know, for 70 years, Taiwan separated from mainland China. And for the initial 30, 40 years, they are doing things the other way. Okay. For example, if you are lining up people, you say the left, look at the right. Okay, so you line up. And then in China, you don't say left, look at the right. You say look at the left, because left is better. Okay, so right thing is not good. You cannot go there. Okay, now or conservative, this is the liberal, whatever. Okay, anyway, the other thing is the Taiwan is because the traditional Chinese character is written from right to left, just like Hebrew. Okay, or else. Now, so the right to left. Now, then most English and books and Arabs and other nice printed thing are now have more and more left to right written that way. So after 30, 40 years, Taiwan also opened up to say, okay, we do things left to right. Both sides are okay. Okay, so that's creating a problem. When I take a trip from arrive in Taipei and take a taxi to the downtown, so I try to pass the sign of the store. So I first start from right to left. If I don't figure out what I mean, then I try to pass from left to right. Okay, so this is, you may look simple, but actually it's very complicated. One of the key things, the Egyptian hieroglyphs couldn't be deciphered for 14, 1500 years is because they have sometimes left to right, sometimes right to left. Now, so the icon design, so we do something less frustration. Okay, so there's something I plan to do. Okay, to develop something easy to understand, easy to use. Now let's talk about some future conceptual modeling. Why are EIM and variant very popular and for how long time? Conceptual modeling. What research can be pursued in the future? So what are the important topics? So the reason for success for popular, and I keep my emphasis in this talk, is you have to closely match the way human being thinking, how human think. The other thing is we need the rigorous and sound theoretical foundation. The third thing is we need to demonstrate practical application usefulness. So any research, either you do or I do, we try to do at least one of them, maybe 2 or 3 of them. Now, so theoretical foundation. There are many issues discussed in the last 2 or 3 months in this summer seminar. So what is concept? Okay. So actually, we have different kind of domain. We have a concept, we have something in our mind, and then we have creating something in our presentation, and then we have something to put into the computer. So there are different realms we have to convert from one to the other. Then what is a conceptual modeling? Okay. So what kind of things should be included? Okay. and what kind of things should that be included. And there are a lot of speeches in this seminar talking about ontology, talking about logic. That's an important work, and more work needs to be done in that area. Now, in terms of mathematical foundation, and that's something I personally prefer, and also spend time on that. So I developed some algebra, and I think that those algebra can be, continue to develop. And so the graphic is important. The graphics, later on you can see the knowledge graph is also graphics, ER diagram graph, probability, ladder theory, and set theory. Okay. Then you have the integration of data modeling and with process modeling. So we should not just doing just concept data to the model, and then look at the time dimension. And then we have the AI and type of thing. Now, the AI knowledge representation and knowledge graph, machine learning. The software engineering is an area being very active, and we can do more. Another thing, the third thing I keep on pushing, but we haven't done too much yet, is the simulation. Because simulation, also using the concept entity and relationship, at least some of the simulation languages. So we need to do that more. Now, we also link to other fields. There have been philosophy, and because I talked earlier, 2,000 years ago, the philosopher also looking at the entities. What is the entities? Okay, and what the relationship, where the entity exists. Okay, and then we can link to biology, bioinformatics, life sciences, the cognitive sciences. That's something I stressed several times in this talk. How we recognize something, how we think, and that's the important thing. Then we have classification theory, how to classify things into entity type, into relationship type, okay, into a multiple, whether two sets are joined, two types are joined, or intersection classification. Social sciences, I think the human relation is a different kind of relationship, different entity relationship. Actually, it's more complicated than other type of relationship. Then I think I want to stress is the practical application. We need to work harder on the application to, for example, we need to make it executable conceptual model language. So basically, we can develop the algebra and calculus. We execute on that instead of just translate to something to relational or whatever to execute. The other thing is called active conceptual modeling, is to do the conceptual modeling, make it more connecting to the real world, doing the dynamic changes. Now, I want to make a conclusion. The concept of entity relationship is very fundamental. Now, it's triggered by critical needs and also by the Chinese character composition method. Okay. And then you can see there are fundamental set of conceptual modeling principles. We can identify that can be applied not only to the natural languages, but also can apply to other fields like graphic icon design or maybe other fields too. So then there's things I stress several times is we need to look at other fields so that we can get some new idea, fresh idea from other places, as well as to take our idea to disseminate to wider audience. So that's the things I try to argue, try to suggest. Now, the other thing I like to say is the anti-deviation concept can be applied to many fields, not just computer science, IT, IS. It should be the link to other fields. So basically, I would recommend, we have been working together, for a long time, and we should work together much closer, and so extend and refine the conceptual models and strengthen the theoretical foundation and the building useful tools. So here are some of the link, the paper that I want to particularly mention. The conference is next week, and then I think so there are the different places, including this seminar. So there are a lot of places you can get more information. Now there's not only you can get from this site, but also there's a paper to be published soon, and it's available online right now, and should be distributed next week on the analysis of papers in the ER conferences. So some of the paper I mentioned is in the LSU website. It's a little bit old collections, but it's still okay. The other thing, so once the paper is not there, we're talking about the icon design. That was something I presented there. Okay, so hopefully we work together. This will be a breakthrough. This is the sound barrier of the airplane. Okay, jet airplane. Good, thank you. Appreciate the opportunity to share some idea here.